guys, today we are going to do lesson 11.8 where we're going to take a look at probabilities of disjoint and overlapping events. So let's start by clarifying what are disjoint events and what are overlapping events. Disjoint events, or sometimes they're called mutually exclusive events, are events that have no outcomes in common. So the two events would be completely separate. When we're talking about these kind of disjoint and overlapping events, we're looking at 2 or 3 events happening. And so if they have no outcomes in common, that would be disjoint. Overlapping events are events that have 1 or more outcomes in common. So let me give you a couple examples of each to help you understand. You see in the first example here, disjoint event. So if I had event A is rolling a 2 and event B is rolling an odd number. So oftentimes when we're talking about disjoint events, we would say it's the probability of A or B happening. Well, there are no events that could fall into both categories. Because 2 is not an odd number, there are possible outcomes for event A and possible outcomes for event B, but none of those outcomes are in common. Whereas if you look at the next example, where event A is rolling an even number and event B is rolling a prime number, we see that they do have an overlapping outcome. And the Venn diagrams help you here. Because 2 is both an even number and a prime number, it would be an outcome that would fall into both events. And so therefore they're called overlapping because one of their outcomes, or there could be more, so 1 or more outcomes are in common. All right, so we're going to start by practicing telling whether an event is disjoint or overlapping, because that's the first step to solving these problems, is knowing if they have overlapping outcomes or not. So the first example is that you're rolling a number cube. Remember, that's a dice. So event A is that you roll a number less than 4, and event B is that you roll a 5. So we're trying to see, could they have any outcomes in common? Well, if it helps you, to roll a number less than 4 would be 1, 2, and 3, and to roll a 5 would obviously be a 5. So they have no outcomes in common, so these would be disjoint events. B says you are randomly selecting a student. Event A is that you select a 7th grader. Event B is that you select a boy. Well, these are overlapping because there could be a 7th grade boy. There could be an outcome that falls into both events or overlaps. Why don't you read one and see if you can figure out which it is? So if you're choosing a book to read and your events are choosing a hardcover book and choosing a fiction book, these would be overlapping because it would be possible to have an outcome that falls into both events. You could have a hardcover fiction book, and so therefore because outcomes can overlap, these would be overlapping events. All right, so we're going to start by focusing on disjoint events and finding the probability of disjoint events. So if you look at the box at the top, it says for 2 disjoint events, the probability that either of the events occurs is the sum, remember sum means addition, of the probabilities of the event. So if we have A and B, the probability of A or B happening, that's a key word because it doesn't have to be that both of the events happen, it's this or this. We simply add the probability of A to the probability of event B. So let's look at an example. 50 tickets are sold for a raffle. You buy 2 tickets and your friend buys 3 tickets. 1 ticket is randomly chosen as the winning ticket. What is the probability that you or your friend wins the raffle? Well, like we talked about yesterday, because this is probability, our label goes at the beginning. So now we're going to have 2 events. So I'm going to say you or, there's that keyword or, your friend wins. That's the probability that we're trying to find. All right, so first, what's the probability that you win? Well, you buy 2 tickets and there were 50 total, so you have a 2 out of 50 chance of winning. Your friend buys 3 tickets of the 50. So your friend has a 3 out of 50 chance. So if we're looking for the probability that you or your friend wins, we are going to add those 2 fractions together. Now remember, when you're adding fractions, you must have a common denominator. However, on this, we already have a common denominator, so that's nice. It's going to save us 1 step. So 2 50ths plus 3 50ths is 5 50ths. But remember, we always give our answer in simplest form, so I know I could divide the top and bottom here by 5, and I get 1 over 10. So the probability that you or your friend wins the raffle is 1 out of 10. When you're giving your answer, you don't need to write the sentence at the end. As long as you wrote your label at the beginning and simplify your answer, you're good to go. Let's try the next one. Your school's varsity basketball team has 4 seniors, 5 juniors, and 3 sophomores. You randomly select one player to interview for the school newspaper. What is the probability that you select a sophomore or a junior? So notice this has to be disjoint because you can't have someone who's a sophomore and a junior. There's no overlapping events. And I should have noted that on the previous example that those were disjoint as well because you and your friend can't win. One or the other is going to happen. There's no overlapping outcomes there. Okay, so these are disjoint. So it's the probability that you have a sophomore or a junior. Well, on this one I need to figure out how many total people I have, so I need to add my total amount of people, so that's 4 plus 5 plus 3. So I have 12 total varsity basketball athletes. So the number of sophomores would be 3 out of 12. And the number of juniors is 5 out of 12. So the probability of getting a sophomore or a junior would be 8 over 12. Again, these already had a common denominator, so I didn't need to worry or change those. But then I do need to simplify this. So I know that 4 goes into both of these. And so my simplified fraction would be 2 out of 3. So the probability that you get a sophomore or a junior is 2/3. Now, if you look at the next example, you'll notice that it tells us that events A and B are disjoint, and it wants us to find the probability of A or B. But it doesn't tell us what event A is or what event B is, and that's okay. We can still find what the probability of A or B is, even if we don't know what A and B is. So we're just going to, for our label, put A or B, and we are going to simply add these 2 fractions, which again, thankfully for us, already have a common denominator. That makes it a whole lot easier. So when I add these 2, I get 25 over 35. I then need to simplify my fraction, so I know 5 goes into both of those, so I get 5 over 7. So many of the problems that you get will be word problems where you know what the events are, but you can also solve them even if you don't know what event A and what event B is. All right, now we're going to take a look at overlapping events, which we solve very similarly, except there's one extra step. So for 2 overlapping events, the probability that either of the events occur is the sum of the probabilities, just like it was with disjoint, but now we have to minus the probability of both events happening. I think once I show you through an example, it'll make a little more sense. Okay, so you roll a number cube. What is the probability that you roll a number that is less than 5 or an even number? All right, well, we know that these events overlap because there are a couple even numbers that are less than 5. So there are events that fall into both of these categories. Okay, so here's my label, probability of less than 5 or even. Okay, so the probability of getting a number less than 5 is 4 over 6. There's 6 possibilities. There are 4 numbers that are less than 5. Then the probability of getting an even number is 3 over 6. Now, if all I did was add those two fractions, I would get 7/6, which doesn't even make sense. I can't have a probability that's greater than 1. Well, here's the issue. If you go back and think to the Venn diagrams that we made at the beginning of this lesson, if this is less than 5 and this is even, we know that 2 and 4 could fit into both of these events. 2 and 4 are both less than 5 and even. And so if you think about it, 2 and 4 have been counted in this number and they have been counted in this number. But we don't want to count them twice. We only want to count them once. And so to do that, I need to subtract, we call it the probability of A and B. In other words, how much overlap is there? Well, in this problem, there are 2 of the 6 that overlap. It's that 2 and 4 there. And you have to subtract the overlap, otherwise it's getting counted twice. And so now I can add and then subtract. And again, I do have to have a common denominator, but I do here. So 4 plus 3 is 7, minus 2 is 5. So that's my final answer, because it's already in simplest form, that there is a 5 out of 6 chance that you will get a number less than 5 or that is even. In other words, 5 is the only one that couldn't be in either event. So that's the key with overlapping, is that you add the two events, but then you subtract whatever the overlap is, or how many outcomes overlap. All right, let's take a look at another one. It says you toss a quarter and a nickel. What is the probability that at least one of the coins shows tails? Okay, so I want the probability of tails or tails, and it gives you a hint. It says make a table to list all of the possible outcomes. So I have a quarter and I have a nickel. So one outcome is that my quarter could be heads and my nickel could be heads, or my quarter could be heads and my nickel could be tails, or my quarter could be tails and my nickel heads, or tails, tails. Those are my possible outcomes here. Okay, so, well, what is the probability that the quarter is tails? Well, there's a 2 out of 4 chance of that if you look at the quarter column. How about the nickel? Well, there's a 2 out of 4 chance in the nickel column as well. However, I then need to subtract the overlap. And here's the overlap, is that they could both be tails. And so there's 1 out of 4 as my overlap there that I counted in both of these probabilities, okay? So because this column was counted in the first probability and the second probability, I have to subtract the overlap so that the overlap isn't counted twice. So 2 plus 2 minus 1 is 3 out of 4, which is my final answer of the probability that at least one of them will be tails. So the key to overlap probability is you take the probability of each event and then subtract the overlapping outcomes. All right, the last type of events we're going to talk about today are complementary events, and these are actually even easier to solve than disjoint and overlapping. So 2 events are complementary events if they are disjoint, meaning they have no overlapping outcomes, and one event or the other must occur. So the sum of the probabilities of complementary events is always 1 if one or the other must occur. And if you know the probability of event A, then the probability of the complementary event, which we call not A, is given by the following rule, that it's 1 minus the probability of A. Again, I think through an example, this will make even more sense. Okay, so this problem says the forecast claims that there is a 40% probability of snow tomorrow. Not really, obviously, right now, but it's in this problem. What is the probability that it will not snow tomorrow? So do you understand that one or the other has to happen? It's either going to snow or it's not going to snow. So that's why they're complementary, because one or the other event must occur. Well, if you know that the probability of snow tomorrow is 40%, then we can pretty quickly figure out that the probability of no snow or not snowing is 1 minus that 40%. Well, we've already done a lot with probability or with percent. So 40% we know is 0.4. Or you could also think about this as 100% minus 40%. Either way, you can make that 1 a percent, or you can make the 40% not a percent. Either way, we get 60% as my answer. So again, it's just the idea that if I know one event and one or the other has to happen, I can figure out the probability of it not happening. Let's do one last one. You and 8 friends are deciding where to go for dinner. Each person's name is put in a hat. The person whose name is drawn picks the restaurant. What is the probability that your name is not chosen? Well, the probability that you are not chosen would be 1 minus the probability that you are chosen. Because again, one or two of these events is going to happen. You're either chosen or you're not chosen. So they're complementary. Okay, so this would be 1 minus, well, the probability that you are chosen is 1 out of 9 because you and 8 friends, so there's 9 people total. Now, if I want to leave this as a fraction, which is probably easiest, I need a common denominator. So instead of 1, I'm going to write that as 9 over 9 minus 1 over 9. So the probability that you are not chosen is 8 out of 9. So again, complementary events are when one or the other has to happen. And so if you know the probability of it happening, you just take 1 minus that to find the probability of it not happening. All right, have a good day.